Welcome back to our Epochs podcast.
This is episode 2.
At the center of the story lies a simple question. What was the Newton-Leibniz calculus controversy, and why did it matter for science and mathematics?
It's one of those stories that, feels like it should be simple, a story about a discovery, but it's so much messier than that.
Right. It's not this clean relay race of progress we sometimes imagine. It's about people. Ego, ambition, all of it.
Exactly. And to get to the heart of it, we have to start in a time of profound silence.
We're in England, right? The 1660s.
Mid-1660s, yeah. And the Great Plague is sweeping across the country. The University of Cambridge, it shut its doors. Everyone's been sent home.
And among those students is a very young Isaac Newton.
He is. He's just 22, and he goes back to his family home in Lincolnshire. And for about 2 years, he's just alone.
Just complete isolation.
Total isolation. No professors, no peers to bounce ideas off of. And in that quiet, his mind just, it ignites.
These are his miraculous years, as they're called.
That's the term. In this tiny window, he basically lays the groundwork for the laws of gravitation. He figures out the nature of light and color. And for our story, he invents a new kind of mathematics.
But he doesn't call it calculus.
No, not at all. He calls it the method of fluxions. He saw everything through the lens of physics, of motion. A variable was a fluent, a flowing quantity.
And its rate of change was the fluxion.
The fluxion, exactly. He'd mark it with a little dot over the letter. A simple, elegant system for understanding change. It's the key to everything.
So he has this monumental word-changing discovery, and what does he do with it?
He hides it.
He just puts it in a drawer.
Puts it in a drawer. He was terrified of criticism, of scrutiny. He shared it with maybe a tiny handful of people. You know that famous quote of his about being a boy on the seashore?
Finding a smoother pebble or a prettier shell.
While the great ocean of truth lay all undiscovered, he found the smoothest pebble imaginable, and he just kept it in his pocket. And that right there is the fatal flaw in this whole story.
Because while he's keeping his secrets in Lincolnshire,
the world keeps turning. And on the continent in the 1670s, we meet a man who is, in almost every conceivable way, Newton's complete opposite.
Gottfried Wilhelm Leibniz.
Leibniz, the diplomat, the courtier, the man of letters. He wasn't a recluse, he was a networker. He believed knowledge had to be shared.
And he's working on the same problem, but from a totally different angle.
Completely different. Newton saw physics. Leibniz saw symbols, geometry. He believed that if you could create the perfect notation, you could solve any problem.
And he creates a notation that is just brilliant.
It's incredible. He takes the word summa for sum, and he elongates the letter S into the integral sign.
The one we all use today.
The very one. He takes differentia for difference and uses the letter D for the differentials. The thing is dx. It wasn't just symbols. It was a whole system, a language.
And crucially, unlike Newton,
he publishes it.
He gives it to the world.
In 1684, he puts it out there in a journal for everyone to see, to use. And for a little while, there's peace.
Right. It's a strange, quiet period. Newton finally publishes his own masterpiece, the Principia, in 1687. But he doesn't use his fluxions in it, does he?
He doesn't. Not openly. He writes it all in the language of classical geometry. Maybe because he thought that was the only way the establishment would take it seriously. The calculus is sort of hidden under the hood.
So the English have Newton's book, but the Continentals have Leibniz's tools, and they are running with them.
Oh, absolutely. They're solving problems left and right. But the storm is brewing, and the first shot is fired in 1699.
It's from a friend of Newton's, isn't it?
A Swiss mathematician, Nicolas Fatio de Dulier. And he doesn't accuse directly, he suggests. He implies that Leibniz might have, borrowed his ideas from Newton.
Just a whisper.
Just a whisper. But then, in 1708, the whisper becomes a shout.
Enter John Keill, Newton's bulldog.
That's the perfect word for him. He writes in the Royal Society's own journal, and he does not hold back. He says Newton was the first inventor, and that Leibniz simply changed the name and the notation and passed it off as his own.
It's a direct accusation of plagiarism in public.
And Leibniz is, understandably, furious. He's a fellow of the Royal Society. He writes to them demanding a retraction and apology. He expects justice.
He expects them to be impartial.
He does. And that was his great mistake.
Yeah.
Because he walked right into a trap.
So the Royal Society sets up a committee to investigate, to be the judge.
An impartial committee.
But the man who was president of the Royal Society at that very moment was
Isaac Newton himself.
Wow.
And we know now he controlled the whole thing. He picked the committee members, all his allies. He selected the documents they would review. He even secretly wrote the final report himself.
He wrote the verdict in his own case.
He did. The report was called the Commercium Epistolicum, and it was devastating. It declared Newton the first inventor and strongly insinuated that Leibniz stole the idea after seeing some of Newton's letters on a trip to London years earlier.
It effectively brands him a fraud.
A plagiarist, yes.
Yeah.
And it's important to remember this wasn't happening in a vacuum. There's a huge political angle here.
The succession to the British throne.
Exactly. Queen Anne is ill. The designated heir is from the House of Hanover in Germany. And who works for the House of Hanover?
Leibniz.
So, to Newton's political allies, Leibniz isn't just a mathematical rival. He's a foreign agent, a political threat connected to this incoming German king. The whole thing gets wrapped up in nationalism, England versus the continent.
So this report is supposed to be the final word, the knockout punch.
It was meant to be. But all it did was start an open war. The continent did not take this lying down.
And this is where Leibniz gets his own champion.
Johann Bernoulli,
Yeah.
a brilliant and very arrogant Swiss mathematician, and he decides to fight fire with fire. He doesn't argue about dates on letters. He attacks Newton's mathematics itself.
He goes after the Principia.
He scrutinizes it, and he finds a mistake. A small but significant error in a proof about a projectile moving through a resisting medium.
And his argument is,
If Newton truly understood this calculus he claims to have invented, how could he have made such a basic error? He's basically saying Newton doesn't even know how to use his own tool properly.
so they start dueling with math problems.
Intellectual duels. They send these challenge problems back and forth. Incredibly difficult questions designed to break the other system.
And what becomes clear?
What becomes painfully clear, for the British at least, is that Leibniz's notation, his Dictatus integral sign, it's just better. It's more flexible, more powerful.
So the Continentals are solving these problems with ease.
Well, not with ease, but with elegance. While the British are struggling along with Newton's clunkier fluxions, Bernoulli actually boasted he could solve in minutes what took the English days.
It's a complete humiliation in a way. So where does it all end, this bitter fight?
It ends tragically, especially for Leibniz. He dies in 1716, pretty much in isolation. His boss became King George I of England, but Leibniz was left behind in Hanover. He was toxic, politically, thanks to Newton's influence.
And Newton just keeps attacking him, even after he's dead.
He can't let it go. He's obsessed with securing his legacy as the sole inventor.
But what's the long-term cost of this victory?
The cost was enormous. It created a deep schism in mathematics. British mathematicians, out of loyalty to Newton, just refuse to use Leibniz's notation.
They cut themselves off.
Completely. For nearly a century, British mathematics stagnates. They're stuck with an inferior system, while the rest of Europe, with Euler, Lagrange, the Bernoullis, they're racing ahead using Leibniz's powerful language.
So in the end, history's verdict is what?
That they were both right. It was an independent discovery. Newton definitely had it first in those miraculous years, priority of time.
But Leibniz had the priority of publication. He's the one who actually gave the tool to the world.
Precisely. And the great irony is that today, we use a combination of both their legacies. We use Leibniz's elegant notation, the integral, the dx, but we often use it to solve the problems of physics and gravity that Newton first defined.
We stand on both their shoulders, even though they spent their lives trying to tear each other down.
A perfect summary.
Before we end, take a moment to sit with this story.
These moments from the past are not just about ideas or discoveries.
They are about people.
Their ambitions. And the quiet choices that shape the world we live in today.
Thank you for listening.
Until next time.
This was Epochs.